introduce Motti, Senior Software Engineer at Aspecto. Hi, can you hear me?
Yeah. Hi, Simon. It's great to be here.
Currently, I don't think we can see your video. Could you make sure to check that your camera is on? Hi, Motti. Can you?
Yeah, I mean, it looks on. I can see it. I can see my stream.
Okay, I can see your screen, but we're struggling to see your web camera right now. Okay, no worries. We'll continue with your presentation. You're going to talk a little bit about the state of observability. So I'll hand it over
Yes.
and just begin the presentation. Thank you.
Okay. So today we're going to talk about the state of observability. We'll talk a bit about what observability is. We'll review some incidents, how they look without observability, and how observability can help us. We'll talk a bit about some tools, what tools we can use, and then we'll talk about OpenTelemetry, which is a cool open source. A little bit about me. I'm a senior software engineer at Aspecto. It's a distributed tracing company. I've been working with microservices and distributed applications for the past few years. And I've been contributing to OpenTelemetry for the past 2 years, and I'm very passionate about it. And these are my socials, so feel free to go and follow. So what is observability? Observability is a term. It's not necessarily from technology. It comes from thermodynamics and systems. And it basically means to understand the state of a system based on the external outputs. But when we look at applications, we usually want to know, is my application behaving the way that I want it to behave? Is it performing well? If something is not performing well, why? What is happening? And maybe that sounds a bit familiar because we have APM, logs, different alerts. It's something that is familiar to anyone that is using software systems in production because it's something that has been around for a while. So is that observability? So the answer is, yeah, it's part of observability. Observability has 3 pillars, 3 different parts to it. And logs, which are basically a story told by the application. Basically, within your application, you would write a log. Basically, whenever you have some important transaction happening or something you want to observe, you would go in the code, add a log line, and write whatever you want to. You have metrics, which are the numbers, basically a high-level picture of what's happening in your application. It could be an average latency or the number of HTTP requests for a specific route, or anything like number of calls to a certain database, maybe CPU, anything that you can look at from a high level and get like a good picture if it's behaving the way you expect it or not. And then this is the less familiar part, which we will dig into next. That is the traces, which are basically a context within an application. We'll go into that later with a really deep dive example. So let's go and review each one of them and see the pros and the cons and maybe when we should use it. So let's talk about logs. Everybody knows logs. Logs been around forever. And everybody is familiar with it. So the good thing is logs are within the code. We can actually write whatever we want to the logs. It's part of the application, so we have access to any data that we want. If it's a user ID or it's the request that we're getting, we can basically write anything we want to the log. Another good thing is logs been around for ages, so there's a huge ecosystem around logs, standards and libraries you can use, and shippers and platforms you can use to visualize them or alert based off them. Another good thing, it doesn't affect performance very much. And the bad thing, they're expensive. You collect a lot of logs. Basically, every time your application runs or requests, you would log a lot of data. It's unstructured. Maybe you wrote something, maybe a different developer wrote something else. Maybe you have the request ID or the user ID in the log. Maybe you don't. Maybe you want a log, but it's not there. So now you need to go and modify your code and add a new log. So you need to create a new deployment just to add some log to your application. So it's good. You definitely should have logs, but we need to understand that it doesn't solve all our issues when it comes to observability. And then on the other hand, we have the second part, which is the metrics, which everybody knows metrics. It's very cheap to store because it's metric data. It's structured, so you know how it's going to look. It's very easy to create alerts based on metrics because you can say, I want when my average goes up, just alert me. We can measure SLAs, SLOs, SLIs based on metrics to know, let's say if we have a specific endpoint that we have an SLO for, we can measure it by metrics and see the number of requests, the average response time, and see if we have met this SLO. So everybody is collecting metrics. What's the problem with metrics? It's, again, if you want to collect a new metric, you need to make a deployment change. You need to create a change in your application, add a metric, and then deploy it. Another problem, it's a very high level insight. So for example, you might get an alert because your CPU level is very high or your average response time went up dramatically, but that's it. That's all you get because you just get an alert. You just get average response time, but you don't have the details. Okay, I got this alert, but why is this happening? So metrics doesn't give you the answers to that. So you might use logs to understand that, but again, let's see when logs don't help us. So the third part is traces, but before traces, we need to understand why we need them and why traces exist. Because logs and metrics have been around for many, many years. Everybody knows them, we're familiar with them, we have the tooling to use them correctly. So why do we need more than that? And the answer is distributed applications, or the way we call it, microservices. Everybody is migrating to microservices, moving to the cloud. And when we move to microservices, it becomes very hard to debug and understand your service. And let's look at one example to see why it's hard to understand it. So we have a web browser talking to a service, which is talking to a database. And we're getting an alert that a CPU is very high. We get a graph. We look at this graph. We can see, yeah, the CPU is high. What's happening? We might go to the log. We go to the log. We can see that we failed to write DB 5 times in 5 minutes. Okay, interesting, but why is it happening? When is it happening? We might go on the log and look at the log and try to understand, is it happening to all users? Is it happening all the time? Is it happening for a specific application? But when we have distributed applications, it might get a bit more complex because we might have a request coming from service A going to this coolest service ever, but then we might also have a request coming from service B. And now we need to look at this and say, wait, is this transaction failing only for service A, also for service B? Maybe for both, maybe for B and not for A. And then we really don't know because based on the logs are coming from only from this coolest service, but we don't have the full context of the request. We don't know where it started, where it went from, and how it looks between. If we use traces, Traces give us the context. Basically, we look at this error, but we have the context of where this request came from and what happened before. So we can see, oh, in service A, it works well, but in service B, when service B is calling this coolest service ever, then it fails. And then we can understand that maybe something in this request is different, and we can investigate and look into the details of it. And that's a pretty simple example, but we might have a more complex example when we have service A and service B writing to some queue or message broker. And in that case, it's getting very, very hard to understand what's happening, when is it failing, and in this way, our observability with traces gives us an answer of exactly what happened throughout the entire system, the entire flow from service A to the message broker, to the coolest service, and to the database. And the way it looks, this is one example of Jaeger, which is an open source visualization tool for traces. And in this case, you can see how our flow of a trace looks like. You can see a request, HTTP request in one service going to a different service, and then a Lambda, which is a serverless platform by AWS. So you can basically see the different parts of the flow, and you can see exactly how much time each operation took. This is an example of another trace, this time in Aspecto, which is our tracing platform, which you can also see like a graph of your system, how it behaves, and you can actually see a timeline of your flow, and you can understand if you have a latency problem somewhere down your flow, you can actually see where the bottleneck is. So traces sounds like a great thing, but how does it work? How does it know to correlate all these events and create a graph? So the way it works is actually by installing a small piece of software on your services. In this case, we're talking about OpenTelemetry, which we'll explain a bit later what it is. You're going to install on each of your services this OpenTelemetry. And OpenTelemetry, what would do when you receive a request, it would generate, let's say the first service would generate an ID for this request, and then inject that ID in a header. And that way, it would pass the ID down, and then the trace would send the event to a database, and then this OpenTelemetry in service B would also send the request to the database, and then we'd be able to join them together and later on create this trace visualization. So what do you need to actually collect traces? You need an SDK, which we talked about is OpenTelemetry. You need a backend to receive the data. And you need a database to store it, which is Elasticsearch is very familiar. And we need a visualization tool, which is an open telemetry, is supported by Jaeger or Zipkin, or you can use any vendor to collect your data. Traces, the good, the bad, no need for human interaction. You install it once, you collect all of your data, all your HTTP requests. It's structured, it can correlate to logs and metrics. It's new, so it's not very mature. Getting started can be hard and it's expensive, but overall the good looks good. So we have the three pillars of observability: traces, logs, and metrics. And let's talk a little bit about, I said OpenTelemetry. So OpenTelemetry is open source project by CNCF. It's actually the second most active project after Kubernetes. So it's pretty big and it's growing fast. It's becoming the new standard for collecting observability data. And it's actually allowing new players to have observability solutions and compete with old vendors. And it's actually eliminating the vendor lock-in. If you used to be locked into an observability provider or vendor before, now you can use this open source project and basically send your data whenever. If you want, you install OpenTelemetry on your systems, but if you want to use one vendor, you can send him your OpenTelemetry data. But if tomorrow you want to switch to a different one or use your in-house solution, you can basically just change one line on configuration and you basically move away from that vendor. So it's definitely a game changer. And if you're not with OpenTelemetry, if you don't have OpenTelemetry in your organization, you should definitely start looking into it. And it's just the beginning. This is this graph is from Gartner, and this is their technology hype scale. And you can see OpenTelemetry right here. It's just the beginning, and you should definitely follow this amazing technology and see if your organization can benefit from it. So that was it. Thank you for having me. It's sorry for my camera not working. Do you have any questions?
Okay. Thank you, Motti. We actually have to move on to our next speaker due to time. But thank you very much for your sharing.